I'm Mark. I am from Washington, D.C. I work for Microsoft. And just a kind of, there we go. So I'm a technical solutions specialist at Microsoft. I focus on the Azure cloud stack for data and AI, so everything that's related to all of our managed services and our on-premises stuff related to data science, analytics, artificial intelligence, and whatnot. I help the federal government, folks in the federal government, adopt our platform. And what's been really cool is that there are actually pockets of the federal government that are definitely using R. More and more people are using R. And it's a lot of fun. So about me, just want a disclaimer. So I am affiliated with a bunch of organizations. Again, Microsoft. So yes, Data Community DC. Data Community DC was started after Harlan moved to DC. I was working the R meetup. Then we started the Data Science DC meetup together. And over the years grew to over 20,000 people. We have a reach of over 20,000 people across different programs. So Jared, we have over 20,000 people.
For multiple meetups, though, it doesn't count.
It doesn't matter. It's 20,000 people. Let's see, what else? I also am an adjunct professor at Georgetown and at GW. I teach a big data course where in the Masters of Analytics. So I teach students how to use Hadoop and Spark and how to do a lot of, I would call it like systems / DevOps / Linux / everything else they don't teach you in all the other classes, and really help them embrace this idea of working with computing systems, right? Because it's very different for you to start up an R session and do read_CSV, read on a file, do some stuff, write CSV back, to working in large-scale systems, working in production environments, being able to interface with other types of code and things like that. So again, my opinions today are my opinions alone, and that's that. Just a little bit of shout out. Why reinvent the wheel? I hate making slides, so I am just reusing stuff that's publicly available. I have modified some stuff, and I have added some new content. So a shout out to my Microsoft peers. Shout out to Hadley. I saw him over there. Shout out to JD. JD, there you go. And on that note, so let's see. Show of hands. Who has a big data problem? Wow. OK. All right. Well, that's fine. Maybe you'll have it by the end of this talk. Who has experience with Hadoop? OK, a few of you. Who has experience with Spark? A couple of you? All right. Who has experience with Scala? OK. Who loves R? OK. All right. So the idea of this talk is really to show you that you have options of working with big data. You might be scared of it, especially, I know a lot of people work with smallish data sets, and that's fine. And I come from doing large-scale data analytics, usually from a business context. That's my background. I have a background in mechanical engineering. I have an MBA. Yes, I'm a data scientist and an MBA. Weird combination. But over the last few years of my career, when I started getting into the R community and doing data analytics, and I started learning R after running the meetup, I really fell in love with the community and really started using all these available tools. I started using Hadoop and R back in 2010. There's still a couple of Stack Overflow questions from that time. Of course, JD was a good contributor to that, because he wrote the first Pi simulation on R and Hadoop streaming, like in 2010. That was a lifetime ago. But really, the fact is that the ecosystem has matured. And I know that for many R users, getting into sort of this big data stack or big data ecosystem is sort of, it's sort of like a little bit of a fear. So hopefully by the end of today, I will take away those fears and give you the tools or give you the ideas to go and let you go and play around with big data. Oh, I'm also here to recruit speakers to the DC meetup. OK, so first slide stolen from JD via Hadley Wickham or vice versa. So when we talk about big data, or at least when I talk about big data, it's really a lot from the business context where you have a lot of long data, right? I think Yuri or Sandra made a reference to clicks and logs and stuff like that. You have a lot of transactions. Normally, you're not working with all of it, right? You're always aggregating it, bucketing it, or whatever. So the idea of working with big data 10 years ago was probably really getting your big data into teeny data and then pulling it out of your cluster, loading it into R on your local machine, or Python, or whatever, and kind of doing your visualizations, doing your analysis, whatever. So today, I think the story has changed a little bit. Big data is still big, but you can take it down to less big data because you have the computing power to be able to work with individual data sets on relatively large machines. So case in point, you can start up a cluster, not a cluster, you can start up a single instance on the cloud that has several gigabytes of memory and do your analysis there. But then there's the other side of it, which is it's really big, it's already spread, it's already scattered, and how do you work with that? In the old days, you would have to kind of figure out how to extract data from databases, large data sets, gigabytes. I'm not necessarily talking about the petabyte scale. I'm keeping it to hundreds of gigabyte scale here. Extract it and figure out how to work with it. So today, with the advent of the cloud, it's really easy to work with. And there's other tools about it. So again, the same idea of the big data, that most of the time, you can take big data, reduce it to a less bigger data set, and then work with it. At the times you can't, there are tools for you. And that's really the focus of this presentation. And the thing is also that today, especially with the advent of IoT, there's a lot of data that's being generated and streaming all the time. So you have to figure out how to work with that. And that's long data that you have to aggregate and ingest. So a lot of the work that I've done over the years has really been about making data work, finding tools, like setting up the right tools and environments for folks to do their analytics, right? Because as I said before, it's really different to start up your laptop, download a data set, load it into R, do your stuff, save it, do a model, whatever. It's really different when you're working with large data sets. It's also very different when you're working in a shared user environment, when you're trying to break down silos. You see this a lot in the federal government, but you also see this a lot in industry, which is every organization within a company or an organization in every group has their own sets of tools, their own sets of methods, and I think we're going to see this theme over and over today, right? But the idea is setting up an analytics environment for multiple people is not easy. So part of this is also, number one, knowing the tools that are available to you, and number two is there also is an aspect of, I'll call it data engineering for lack of a better term, that you do need to know and do need to be a little bit aware of or proficient in to really be able to take advantage of this ecosystem. Why is this not moving? So, this is R working in general, right, and in normal and large scale. So we take a data set, we load it into memory on a single machine. There's been a lot of work over the years to make the data replication less expensive, and thanks to all the folks in our studio and in our community that have taken the tidyverse and all the other tools that make it a lot easier to work with. But inherently, R is single-threaded. There's no inherent parallelism. So there's many ways to approach this problem. So 5 years ago, I don't think you can see that, but 5 years ago, we gave a talk in DC about R for big data, and there's all sorts of, I know you can't see it, but this is just like a little mind map of all the different things. And the big boys back then were down here, like RHype, which is an R Hadoop integration, RMR, and some of the early stuff that the Revolution Analytics team was working on, the XDF, Revo Scale R, and all that stuff. Today, I think the ecosystem is a little bit different. So you have, the biggest thing, what I think really makes reduces the barrier to entry are these packages up here. So you've got SparkR, which is actually part of the Spark ecosystem. It actually is built into mainline Spark. There is SparkLiar, a package written by the RStudio folks that really lowers the barriers to entry for our users into the Spark ecosystem. There's Revo Scale R, which is part of the Revolution distribution of R, which is now part of Microsoft. And then there's H2O, which is a machine learning platform for distributed data. There's other tools, right? The stuff on the top is what I'm going to focus on today, the first two actually. And then just so you know, there's also other packages available if you don't know about them. So there's big memory, there's FF, and kind of the 4H and do parallel backends, which allow you to do parallel computing on your local machine, taking advantage of multi-threading, I mean multiple cores, and or setting it up on something, something like this, where you have perhaps a cluster of R machines where you can actually distribute your work. And this is more along the advent of high-performance computing. That's not what I'm going to be focusing on today, but this is just good for reference. These are some of the different packages and distributions and how they, the advantages they give you. So, CRAN, like regular R, works on single machines. These other packages gives you the ability to work on single or multiple machines or use clusters as the back end. And then we move on to Spark. So not many people use Spark, but are you guys familiar with Spark? OK, so for those that don't know, or for those that do, so Spark is an open source project. It's basically a distributed computing platform for general computing. And it's gotten traction because what it changed is that it actually uses memory and or disk, as opposed to just using disk. Hadoop is just a batch process, read in, read out, which was very effective when it came out. A lot of folks were using Hadoop back in the day, and they still are, because Hadoop is really, or Hadoop and MapReduce is very good for certain kinds of jobs. There are other kinds of tasks where Hadoop is really not that great, and that's where Spark, I think, has really made a big impact on the big data ecosystem. So what Spark allows you to do is really take advantage of memory, in-memory computation. So that works really well for machine learning, where you have to do multiple passes on your data. Sometimes you can't do machine learning in batch mode. Or if you can, but it's going to read it once, read it a second time, read it a third time, and so on and so on. And when your data is in the multi-gigabyte or multi-petabyte scale, you have a time problem. So Spark gives you the capability of doing large-scale computations. It really abstracts a lot of the cluster management for you. And these are kind of the building blocks for Spark. So on the top, you've got the APIs that interface with Spark. So Spark is written in Scala. So of course, there's a Scala API. There's a Python API. There's also an R API and Java. Scala and Java are interchangeable. The four building blocks, kind of the different threads of Spark, what it gives you ability to do. So you have Spark SQL. So Spark SQL gives you the ability of doing structured data analysis using SQL-like commands. Then Spark Streaming is doing analysis of real-time data as it's flowing. Spark MLlib. So the Spark team has actually coded a lot of machine learning algorithms already that are available for Spark. You probably get about 90% of the way there with what's out there with Spark. And then GraphX is a graph API on top of Spark. And then Spark what's cool about Spark is that it gives you the ability, you can run it on different kinds of clusters. You can run it on a Hadoop cluster. You can run it on a standalone Spark cluster. You can run it on a single machine. And it lives alongside Hadoop and MapReduce. So SparkR gives you SparkR is built into Spark. It actually gives you the ability to interface with the RDDs, which is the Scala's sort of low-level data object or data structure that's available in Spark. And then over the years, there's been the development of higher-level APIs for Spark, including Spark SQL and the Spark data frame. That's where SparkLiar comes into the place. I will just jump here. So what SparkLiar allows you to do is it really allows you to use Spark as a backend, and it really fits in well with the tidyverse. So it just it creates the connection object for you. It translates tidy code into Spark SQL, and it runs stuff in the backend. It doesn't do everything, but it gets you, I'll say, 90% of the way there. And so think of it as using R as a front end, right? You're using your R console, whether it is on your local laptop or it is running on an R server in the cloud. So your R instance becomes your interface to the cloud. So that also abstracts the fear of dealing with clusters and kind of dealing with all of the DevOps and, like I said, data engineering stuff that comes attached to that. SparkR, SparkLiar, what the Spark. Thank you. So I just found this blog post recently. This fellow, Ed, just kind of did a comparison of SparkR and SparkLiar. So SparkR is part of the Spark distribution. It gets installed on a cluster when you install Spark as of, I think, 1.6. Right now, Spark's at like 2 or 2.3. And then SparkLiar is, I think it's at 0.7, but it's progressed a lot over the last year and a half. So, again, thanks to the RStudio team and everyone involved with building all those great tools for us to use. This gives you a high-level overview of kind of the difference. So SparkR is really meant to interact more. You can do a lot with both. I think some of them have particular strengths and weaknesses. So SparkR gives you the ability to interact mostly with the RDD, which is the low-level data structure in Spark, whereas SparkLiar gives you a better way to interact with the higher-level objects, which are the Spark data frames. One thing I read that's not necessarily here, and this one kind of contradicts, is my understanding was that running arbitrary code or user-defined functions was actually easier to do with SparkR than with SparkLiar, but and this says otherwise. Again, I don't know much about that, but the key thing here is the tidyverse compatibility. So as you see here, basically, you can just write a DeepLiar statement. You start your, there's the code for starting your cluster is not here, but let's say you start your cluster, you interface with the cluster, you create your object, and then you just refer to your table as if it was a data frame. And you can use that object as part of your tidy code. And then that gets shipped off into the cluster in the back end. So I guess it's part of the tidyverse now. So one thing I did want to mention is one aspect of working with big data that's really hard is setting up your environment. There are many cloud providers out there. I work for one of them. But truth be told is one of the challenges that I was faced with early on was really setting up the environment the right way, because it's not just starting a cluster, right? You can start a cluster really easily. But if you want to work with R, if you want to work with RStudio, if you want to work with all your R packages, there's really a lot of DevOps work that's involved there. And before I used Azure, I did all that stuff manually. And it was a royal pain. I'm not saying this because I work for Microsoft. I'm saying this because I truly believe it. The Azure platform really makes it really easy to work with these tools. So you can actually start up a cluster with R and RStudio already installed, and all you have to do is run with it. So that, for many folks that don't have that skill set of data engineering, sysadmin, DevOps, all that sort of stuff, it makes it really, really easy. So, and we have a whole slew of tools, right? So there's R, there's Microsoft R, then there's Revolution R. But as you can see, it really fits into the big data ecosystem. We recently launched the Databricks integration with Azure. Databricks are the folks that actually wrote Spark. The folks behind Databricks are the folks that wrote Spark. And it's now fully integrated with the Azure platform. And it's truly amazing. It's really a cool interface because it's even a higher level interface than using Spark on a Hadoop cluster. It's a Spark cluster. And this is a platform as a service that just sort of takes advantage of running everything for you. But like I said, I'm really trying not to be pitchy because I'm not. But it really makes it easy to work with. And I'm happy to talk offline about the tools, and how to get you folks involved. So some parting thoughts. So don't be afraid of the big data tools. The ecosystem has evolved. There are more options for you out there. There's HPC options, there's multi-threading options, there's Spark options, there's Hadoop options. I would encourage you to learn a little bit about data engineering, leverage in-database analytics as much as you can so you don't have to move data around. Just a little bit of side note. A lot of times, the examples that are available online refer to a data set. Most of these are open, but they're not readily available. So over time, I've been collecting those publicly available data sets and making them more readily available. They're not zipped. They're actually ready to use. So I have two. I have a S3 bucket and an Azure bucket with some large data sets, including the New York City taxi and some others. And I just would encourage you to try Azure as a platform. So please come visit us in DC. If you'd like to speak at DC, let me know. We would love to have you. So thank you very much.